Welcome, everyone, and thank you for joining our Geomagic Design X Product Spotlight webinar. This webinar is focused on long-range mesh construction in Geomagic Design X. I appreciate you joining us today, and I hope you will be able to join us on future Product Spotlight webinars as well. A few housekeeping items before we get started. As you may have noticed, all attendee lines are muted upon joining the webinar. Therefore, please use the Q&A button on your screen to submit any questions as we go along. In an effort to abide by our 20-minute time allotment, we will not address questions live. However, we will follow up with you after the webinar with an answer to your question. Additionally, we will make the answers to all frequently asked questions available for all of you who have attended. Finally, in a couple of days, you will be receiving a follow-up email with a link to view the recording of this webinar, as well as a copy of a sample file that can be used to trial long-range mesh construction. Once again, thank you for joining us today, and now I will pass it on to Adam Moraxa, a Geomagic application engineer, as he will be leading today's demonstration. Adam, it's all yours.
Thanks, Lisa. Hi, everyone. This is Adam. I'm an application engineer for our Geomagic products here at 3D System. In today's product spotlight, we're going to take a look at importing and doing some basic things with long-range scan data in DX. So what do we need about long-range scan data? So we're looking at things on the order of several meters to hundreds of meters in distance. So these are things that we would gather from large equipment scans in the mining industry, even some architectural applications like this couch pictured here. This is also a picture of a full plant that is going on, some sort of chemical processing. And we do a lot of different things with oil and gas, airframes, archaeology, even in automotive. Some other interesting applications are shipbuilding, and then like this is a scan, believe it or not, of a well system. So there's a lot of different things we can do with the data. So what are we looking at for long-range data? So medium to long-range data is usually captured medium with handheld scanners, and then handheld scanners are usually also used to increase the quantity of data at closer ranges of objects of interest. And then for longer distances, we're usually looking at some long-range photogrammetry or these style of laser scanners that you've often probably seen in architectural or construction sites or mining activities to collect data. And then also there are some applications where sonar data is used, like in that well setting. So what are some of the things we're going to look at today? So we're going to look at this house that we did here, a little bit of newer construction. We'll go over some input options and what happens when we bring things into Design X, how we can have different units on input and things, and what kind of file types we're looking at. We'll go through some cleanup. We'll show you some different view things that we can do. And then we'll show you some things that we can do with points even before we get into meshing activities. So let's jump over to Design X. So starting off in our Design X environment here, should have a clean slate. And what I'm actually going to do is pull in a single one of these FLS scans that are here. There's a lot of different file types from scanners that we can import. So, things that are manufacturer specific, but then also like all kinds of generic things. One of the big file type that's often used for medium and long range data is this ASTM E57. And there's a lot of different information that can get carried over in the standards, so it's a great new file type that's been out for the past couple of years that we can also import. But let's pull in a single one of these here. You'll notice that when you import large scan data into Design X, that you get this little pop-up window. So what we can actually do is look at the range of data from the scanner on some of these files of what we may want to exclude. So maybe we took scans, at full envelope. Now some of these large scanners, that full envelope could be almost a kilometer's worth of data. So you might want to narrow that down a little bit. And then if we say, 0, we could full range, but we could also touch it. We could also change the units of the scan data that we would for importing here. So I'm just going to hit OK on this. And I usually pull in, if there's multiple scan settings, I usually will, as I'm starting a project, pull them in generally one at a time, just to see what's going on, to see if maybe the data was processed or clipped, or if it is indeed full range on the scanner and there's a lot of extraneous stuff on the outside edges we don't need. So as this is processing here, again, we're looking at scan data sets in these long-range data where we're looking at 10 million points, if not more, at a shot from a long-range scan. So the other thing that we usually get when we bring stuff in here too is a confirm of the units. So it tells us basically what the working bounding box is of the unit of the scan here. So we're looking at 452 meters of envelope data, so probably plus or minus 200 and some from the scanner that it could see. So I think that's about right for this sort of application for the house. So as I bring stuff in, you can see this is one scan set. So this is just all the stuff that we could see. We could see that this hasn't been cleaned up at all. And then I could find our central point here. Usually with a long-range scanner, you'll find a very convenient hole on a single scan of where the tripod was, where the scanner was sitting. So as we bring in data now, we can check it out and we can see how things are going on with it. You'll notice in DesignX, if you've only used it with short-range data, you'll notice that as you zoom in, we keep zooming and zooming and zooming, and we're really just zooming into the points. Which is greater for small parts and when we're working on individual objects. But when we're dealing with long-range data and we want to sort of move around and get a feel for it, one of the best things to do is come over here and go into walkthrough. Now I usually do make a button for this up on the toolbar when I come in and use it a lot. But now you'll see when I scroll my mouse wheel, I'm actually flying forward. And there's some with the right-click options here that you can see in our menu. There's a couple different ways to move around and fly through your scene. So right now, if I hit Shift, I'm doing essentially an up and down, left and right. So this is sort of a pan through my scene. Rotate behaves a little bit differently. So now instead of rotating the model, I'm rotating a camera view. And as I zoom in and out, again, I'm flying back and forth. And then I can also come in and with the control key, do like a full pan fly around, which is nice. So I can really get a feel for the lay of the land of what's going on with my scan data. You'll notice I'm not on the beefiest computer here, so as I move around, things can look a little bit juddery, and my display settings can look a little bit fuzzed out, which is again why I try to limit some of the things that are being displayed initially on. Things to help you out in here are the dynamic draw and DesignX, and then these display ratios. So if you put these guys into our auto settings with dynamic draw on, it'll greatly help you move and rotate things around, and it'll de-res the data accordingly to sort of what your graphics card can handle. As you're bringing in larger and larger sets, bumping up to higher end quadro cards is always recommended. What we can see right now is we're just a single scan. We're at 12 million points of data. So you can see how these things can compound as we get higher and higher. The other thing I'd like to do is I will exit the walkthrough view right now, and I will zoom back out. Another thing that can greatly sort of help you out is in display settings is what we call the view clip. So some of you may or may not have used this if you're DX users, but what I usually like is between planes is nice. I really like the sort of inside box of a view clip here, and what I can actually do is hide data that I'm not working with or don't really want to see right away. This is very handy for just getting a better handle of what's going on. We can see in this that there's a bunch of trees in the way, and there's all kinds of stuff going on. Now I know I made this kind of small on the display here. And I could even chop out stuff by height if I want to for some of that larger stuff. But now we can see we have a much better handle of just a smaller scene here. So when I turn this on, it's easier to get around. You'll also notice that my display is behaving a lot nicer, since it's not having to render some of even the things on the fringes of the screen. So so let's go in and actually turn this back off for view clip here, and we'll do some cleanup just to limit our data set. So as I uncheck this, you can come back in, and we're just going to be interested sort of in the front of the house here with the driveway. So let's come into our selection tools, and I'm going to turn off visible only here, and what I'm going to do is I'm going to grab most of the area that I'm looking at. So I'm just going to say, let's grab this front of the house here, and maybe out to the street level. So, and then the easiest way to get rid of everything else is just to do an inverse selection and hit delete on that guy. So again, we're deleting a lot of points, so it's gonna take a second to write to our undo file here, just in case we didn't want to do that. And it will get rid of all of them. So now you can see we have a much healthier model. Or most of the time, you may want some of that for envelope data in the background, so sometimes you section out scans. But now we've greatly gone down in point count, which is nice. So let's look at a couple things that we can do while we're still here. And just for fun, I could work in the view clip if I want to, again, or I could just delete some of these trees out of the way. So it really just depends on what I'm interested in doing. So let's just for fun go back in and pull out our bounding box view clip here. And I'll just hit reset on that to get it closer to where I'm actually at. And I'm going to come in just to get some of these trees out of the way so we can see. What's great about using view clip is we are not getting rid of any data. So it's still all going to be there. We can always view it at a later time, but it just allows us to look at different things. So a lot of times, first thing you might want to do is we can throw a couple, you might want to extract some geometry out. So what we do for that is, even though we're still in points, I can come in and do some of the same things that I would do in a mesh here. Now I have to be a little more careful. So if there was a bunch of stuff behind where I'm highlighting or selecting, I have a tendency with points to highlight that data also. But say I wanted to, set this walkway, which probably has a little bit of a gradient to it, just as like a neutral plane here, I can still come in and extract out a plane for that entity. I don't have to create a mesh right away on stuff like that. Also, if we were going to draw like maybe a front elevation on this house, I could come in and even simply come in and draw a line, or I could use a standard plane if we wanted to align to one. But I could come in and grab. Let's grab some data on the front brickwork of this house. So I'm just going to draw a line, and we'll just stick it roughly down the middle for right now, just for time's sake. So if I want to come down in front of that door on my brick face, just to grab sort of a neutral plane there, we could always lock stuff in how we'd want to if we're actually modeling. But there's also things in here too, is we call this mesh sketch, but believe it or not, as you come in and you grab one of these sketch planes here, you'll notice that we're getting the same type of view and data that we would get if this was a mesh. So, but we're doing this on points right now. So again, it's just adding utility to the fact that as we mesh, like we can definitely use that to extract some more things out for different types of geometry and different types of things. But often you just want to come in and you want to grab some reference points, or you want to make some reference geometry, or maybe we even want to pull out the face plane of this house. Now I can come in and hide my scan data, and if sometimes it gets a little confusing with the amount of data that's there, but you can see that this is actually our door and our wreath. Here's the brickwork above that, and then there's an inset for our window, and then there's some further trim up here. So right now I could actually come in and do something like a standard sketch like we normally would do, and I can just come in and fit to that pink poly line for where the front of my house would be. Exit that out. Turn my scan data back on. And that's sort of the beginning of me, extruding that wall out. We could do this horizontally or vertically or whatever, but, I have a definite CAD sketch now. So if I wanted to extrude a surface out of that geometry for my front fascia, I could do that. We could also go along and fit points to this, to create another virtual plane there and things like that, just to check what's going on. So talking a little bit about going into submeshing as we're going along here, what I'll do is hide these planes, and I'm actually going to hide my reference sketch out here. And we can come in and talk about some different sort of meshing methods. Oftentimes, you will not mesh a whole model altogether. Now, if I brought in scan data from wrapping all the way around this house, I would usually mesh this in sections. So I would usually do each scan sort of individually, and often I may or may not combine them depending on what type of thing I'm trying to do. If I was going to, CAD out a block of this, or even just create sort of a polygonal model that had texture on it, I might keep them separate until near the very end, just until I get everything lined up and have my reference geometry out. It's just going to decrease processing time. So let's go into our point stuff here. So one thing that we created essentially just for this, or with this in mind, I should say, is HD mesh construction. This is one of the best things that HD mesh construction is for, is when I have data that may be a little bit sparser in different areas, and you can see from our scan direction that there is some sparseness to the data. But we still may want to create meshes just to more easily pull things out where the roof is and things like that, or different elevations. But we can come in with this, and this is actually going to triangulate things, plus do some boundary extending to fill in certain areas, and you'll see what I get here in just a second. So, but this will come along. Mesh all the things there. It's still going to keep the texture from the points projected onto the mesh, and with some of the different things that we can pick here. So this high definition filter is more and more that. We're going to increase and increase and increase triangle size, so they get smaller and smaller and smaller as we go to UHD. So again, you may end up, if you crank this all the way, you may end up with a very, very highly dense mesh that may be, to greater levels than you'd really want to work on. You don't necessarily need, a couple thousand points on every brick just to tell you where the front wall is. Same with noise. I usually leave this sort of in the middle of the range here, but if I, if I had some surfaces that were pretty jagged to begin with, I might turn it down. If I would have had all of those trees in there and things like this, I may have actually turned it up a little bit just so I wasn't getting, all these sphered meshes of these tree leaves. As it is, we're going to get a little bit of tree mesh going on here to begin with. A couple more things about this. Remove original data will do just that. It'll get rid of the points automatically. The shape of the field area, usually on long range data, I would probably leave this as flat for things like this, like buildings. If we were doing something that had a bunch of piping in it and things like that, like like a chemical plant or something else, we might want to turn this over to curved here. And then the boundary extension is just where, we're going to get some hole filling, like so where there might be some holes on the front of this door here where the line of sight was off, or some stuff on the windows. We'll extend some boundaries in to fill some of that stuff on the actual mesh. So you can see what it did right there is it did fill in a good amount of that stuff that I was talking about. We do have a hole here behind where the scanner couldn't see behind these trees and this fence here, so that's to be expected. Other scan data sets would make up that data as we had other scan sets from their side of this house. But now that we have a full mesh, we can go in and do all the normal things that we would use to work with meshes. One more thing I'd like to talk about, as we're almost out of time here, is the ability to go in and use, I'll just hit on doing this for a second so I can get back to some points. In some challenging settings, HD mesh construction it may not give you exactly the results that you want. So if I had a ton of scans together and I was really going to go through all of them and I wanted to create something pretty complete, or even just on this front fascia, it's very good. But we do have some other methods here, and the one I want to talk about is 2D triangulation, and then being able to use the spherical projection method. So what this is going to do is it's going to take into account your scan direction, and then it's going to go in and tessellate all of your data based on that. So it's going to figure out where the scanner is looking, and where all the points are coming from, and then it's going to go through and it'll do some automatic filtering based on scan angle and things like that. So you can actually really end up with some nice surface data, and you will notice when you run stuff like this 2D triangulation and this method, some things of high incidence angle, like leaves on this tree where the scanner was hitting them pretty flat, they will get edited out of the scan data essentially, because it'll say the accurate positioning of something like that with such a high degree of incidence to an almost planar tree leaf that's in the wrong direction, or the top of a banister or something like that, isn't necessarily going to be an accurate measurement. So it could pull some stuff out like that for you, and it's very handy if you have a lot of scans in some very complex geometry. But I usually go through one scan setting at a time again and do the 2D triangulation to get meshes of all of them for the areas that I'm interested in anyway. But that was a sort of brief overview of pulling some things in and working with them in DesignX. There isn't really an upper limit to what the software can handle. I pulled in point clouds that were hundreds and hundreds of millions of points to work with. It's more usually just graphics intensive at that point, where you have to turn some things down and use some of that clip tool to make your life a little bit easier. Again, working on getting rid of data you don't need and working on like a scan-to-scan basis can generally speed up the process too and make things a little bit lighter for you. A couple other things I'd love to talk about is grab some more information. Our website has a host of stuff on software and applications for those different software packages and what the solutions are for. Our sales team can definitely get you pricing on things, individual products and bundles of products. Our getting started.geomagic.com website is, I feel, an underutilized resource. There's a lot of things on here as far as videos, workflow stuff, tips and tricks, and then a full knowledge base of even facts and questions about getting stuff done is a great thing to share today. So as Leisha mentioned earlier, we will be sending out this file for you to try out in DesignX along with the recording of this video. And I'd just like to thank you for coming back and checking us out. Lisa, back to you.
Thanks, Adam. This brings us to the end of our Geomagic Product Spotlight webinar on long-range mesh construction in Geomagic DesignX. Please be on the lookout for invitations to future DesignX product spotlights from 3D Systems. In the coming days, each of you will receive an email with a link to the recorded version of this webinar, some useful links regarding DesignX, as well as answers to frequently asked questions. If you ask a specific question during the webinar, we will be sure to follow up with you to answer your question in a timely manner. Thank you again, everyone, for joining us, and have a great day.